So today what we're going to do is we are going to take a look at relations, functions, domain, and range. So in your notebook, at the top of it, turn to a new page and let's title it Relations, Functions, Domain, and hopefully this will fit, Range. So the first thing you need to do now is go back to your table of contents and write it in there too, whether this is page 3 or 4. Make sure you get that labeled. So first thing we're going to talk about is a relation. What exactly is a relation? All a relation is a set of ordered pairs. And we could be talking about any sort of input and output. So for example, we could have 3, 5, 6, -2, 6, 4. All that is an input and an output. You sometimes see these as input-output tables as well. Input, output. And you might have any values here. We might have 1, 2, and 3 in an input, 5, 6, and 7. And just each input is paired with an output. Now on your tables, or you'll have to grab one of these, you will have this sheet of paper. What you need to do is cut around it. You need to glue down just this tab, and then also with your scissors cut here and here, because we're going to be writing underneath these flaps there. So pause the video. Once you have that done, you can start it again. So the first thing we're going to do is talk about a function here. And I can't lift up these flaps to write underneath, so you'll have to do the best that you can here. You can lift these up and write underneath them. So what is a function? So a function here, we talked a little bit about this yesterday, is every input has one distinct output. Now, I'm going to list some coordinates here. So let's say we have a couple of relations, 2, 3, 3, 5, 4, -3, and maybe we have another 2, 3. Then we have this different set where we have 2, 3, 3, 5, 4, -3, and 2, -6. And the highlight the difference is right down here. So you'll notice this function on the right, 2, 3, and 2, 6. Over here we have 2, 3, and 2, 3. So to be a function, every input has one distinct output. So if we input a 2, out pops a 3. Again, a 2, out pops a 3. So this is a function, where this one is not, because we have 2, 3, and 2, -6. There are two different outputs there. Now yesterday in the Desmos activity, you also talked about the vertical line test. So some of you guys may remember from last year that vertical line test helps us determine if there's distinct outputs. Because if we draw a vertical line at an x value, so maybe this is like x equals 2, it only hits our graph once, so there's one distinct output. Where if we were to draw a vertical line here, we have 1, 2 distinct outputs. It's kind of like saying if we were to use the coordinates, maybe this is 2, 3, and down here is 2, -2. So the x value is 2, but there's 2 different outputs. So on this third flap, just some examples of functions and non-functions. So you could graph some, so we could think of a couple functions here. And you could write these underneath. We have a function, a line would be a function. You know, we could have something like that as a function. And then some non-functions. We might have maybe something, you know, that doesn't pass that vertical line test, the letter S. You might have, you know, something like this. Again, it doesn't pass the vertical line test. So the next thing you're going to do is turn your notebook, and you are going to paste, can't see the whole thing, but you should have this chart right here. We're going to talk a little bit about domain and range here. And you guys are set with the inequality way. So if I was to ask you on this first image, what is the domain and range, you would look at this, and again, domain, reading left to right like a book. So you are going this way, starting here. It's -3 in the last place. We have a value is 1. So you would say -3 is less than x is less than or equal to 1 because of that closed-in circle. And then our range, going from low to high, we'd start at -4 and we go up to 1. So our range, we'd have -4 is less than or equal to x, not 1, excuse me, 0 is less than or equal to 0. I have that equal sign because it hits the 0 right there, even though it doesn't over here. So you guys have done that inequality. What we're going to talk today about is a couple different notations. So set notation. In set notation, we're using the brackets, and we're going to say x such that, and then we use that inequality notation. -3 is less than x is less than or equal to 1. And what this takes away is we don't need to write like the domain. Our y values, our range, we can say y such that -4 is less than or equal to y is less than or equal to 0. So interval notation, this is probably the one that takes the longest to get used to. Interval notation uses parentheses and brackets. Parentheses match up with the less than, greater than. Brackets, less than or equal to, greater than or equal to symbols. So our x values, our domain, it didn't include 3, so we're going to put a parenthesis, -3, comma, 1. And then we close the bracket. And we like to label this domain, so we don't want to get these mixed up with coordinates. So our range, we would say, would be -4, comma, 0. So we're going to see if we can fill in this chart here. So this next one here, our domain. Well, reading it like a book here from left to right, there's values, a little break, values, a break, and then values. So since we're just missing a couple, the easiest way would be to say all reals, except x doesn't equal -2, 3, and 4. So we can just exclude a couple values there. And then our range, again, our range, we're going from the low to high. There's all reals, except we're missing that value right there. So that looks like at a height of 1, so we can say all reals, except y does not equal 1. So in our set notation, we start with that bracket, x, and this is the notation, we say an element of the real, so that e means element, and then we can say x does not equal -2, 3, and 4. And then we can do our y such that y is an element of the reals, except y does not equal 1. Oops, and I missed something up here. We should say we have to have x such that x is an element of the reals. And then our set notation, this one takes a little longer in set notation. So our domain, Since it goes on forever to the left, we're going to say negative infinity to negative 2, and it doesn't include that. Negative 2 to 3, 3 to 4, and then we'd have 4 to infinity. And then that range, we could say negative infinity to 3 and 3 to infinity. So you'll notice here infinities will have the parentheses. Now this next one here, let's see, so our domain, it looks like it goes to 0, so x has to be less than 0. In our range, it keeps going up and down, so y, we could say all reals. So then again, in this notation here, we can say that our x, make that fun bracket, such that x is less than 0. And then our y, such that y is an element of the reals. And then in this set notation, so x has to just be less than 0. So negative infinity to 0 would be our domain. And then our range, since it's all reals, we can just say negative infinity to positive infinity. And I should probably label this that this is domain, and this is our range. And then this last one, we have a circle. So if we read this like a book, let's see, negative 4 to positive 4, negative 4 to positive 4. So our domain, negative 4 is less than or equal to x is less than or equal to 4. And our range would be the same, negative 4 less than or equal to x less than or equal to 4. So hopefully you're seeing that this set notation is really, really similar. So we just have to add those brackets, x such that negative 4 less than or equal to x is less than or equal to 4. And then our range, y such that negative 4 is less than or equal to y is less than or equal to 4. And then this one's really nice for the set note, for the interval notation. So our domain from negative 4 to positive 4, and it includes it, so bracket negative 4, positive 4, and then our range would be that same thing, bracket negative 4, positive 4. So really quickly, the last thing we're going to talk about is these asymptotes. You'll notice that graph 2 had asymptotes. And if we go back up to our graph 2, those dashed lines that it never meets, those were at our line, those were at the equations x equals negative 2 and x equals 4. So let's say we have an equation, y equals 1 over x minus 2. If we were to go back and graph this in Desmos, here, let's take a look and see what it looks like. So we have 1 divided by x minus 2. So if we take a look at this, we have an asymptote, and it looks like at 0 going across and 1, 2. I could double check that. So y equals 2. Oops. So it's not at y equals 2. Y equals 0. Yep. And let's see, x equals 2. So we have those asymptotes there. So at y equals 0 and x equals 2. So our goal today is to be able to identify these from a graph. So let's say we have y equals 2x minus 1, x plus 1. Some of you might remember the equation, but if you don't, just go back and graph it. So we have 2x minus 1 divided by x plus 1. And we can see where our asymptote